Hi everybody, today we're going to talk about special triangles and their trig functions. We'll look at the 30-60-90 triangle and the 45-45-90 triangle. Let's start with the 45-45-90 triangle. When we have a right triangle where one of the angles is equal to 45 degrees, then we automatically know that the other angle will be 45 degrees. This means we have an isosceles triangle. So if we call one of the sides across from the 45-degree angle S, then the other side will also be S. The only thing we don't know is the hypotenuse. So for now, let's call that H. To find the relationship between the three sides, we can use the Pythagorean theorem. That'll say that S squared plus S squared will be equal to H squared. Since we have two S squareds, we can write that together as 2S squared is equal to H squared. We can take the square root of both sides, which gives us the square root of 2S squared is equal to the square root of H squared. That simplifies to S times the square root of 2 equals H. Now we know that in any 45-45-90 triangle, we will have sides equal to S and the hypotenuse will be equal to S times the square root of 2. Let me show you how that helps us. Let's say we have a 45-45-90 degree triangle where the two sides are equal to 12. Then when we look for the hypotenuse, all we need to do is multiply by the square root of 2. So instead of going through the whole Pythagorean theorem, the only thing we want to do is take the side 12 multiplied by the square root of 2 and we're done. If we know the hypotenuse but don't know the side lengths, again, instead of going through the Pythagorean theorem, we can remember that S times the square root of 2 is equal to H. This time I called our sides x, so I have x squared root of 2 is equal to 42. We need to divide both sides by the square root of 2. That gives me x is equal to 42 over the square root of 2. We don't like to leave radicals in the denominator, so we're going to do something called rationalizing the denominator. I'm going to multiply by the square root of 2 over the square root of 2, which is just the same as multiplying by 1. What this does is it gives us 42 square root of 2 in the numerator, but the square root of 2 times the square root of 2 is just 2. I took the radical out of the denominator. We can divide 42 by 2 to get 21 square root of 2 as our answer. This says both sides are equal to 21 square root of 2. Let's take a look at how this relates to our trig functions. The sine of 45 degrees is going to be the opposite s over the hypotenuse s square root of 2. The first thing we see is that we have an s in the numerator and denominator that we can cancel. Now that we have 1 over the square root of 2, we'll rationalize the denominator again by multiplying by the square root of 2 over the square root of 2. This gives me the square root of 2 over 2. Cosine will be exactly the same thing because the sides are equal in length, so we know that cosine is also the square root of 2 over 2. To get tangent, we do the opposite, s, over the adjacent, also s. S over s is equal to 1. Let's take a look at the 30-60-90 triangle. To take a closer look, I need to move it over. We're going to duplicate the triangle and flip it around. The reason we do this is to form an equilateral triangle. I have 60 degrees at the top and 60 on each side. Because this is an equilateral triangle, not only do I know all the angles are equal, but I also know all the sides are equal. So if we call the hypotenuse C, we'll have C on the left, we'll have C on the right, and we'll have C on the bottom. Because this is formed by two triangles, we can split the base into a half of C and a half of C. Then we can go back to having a singular triangle. We know the hypotenuse C, we know the side across from 30 degrees is a half of C, and we want to figure out the side across from the 60-degree angle. For now, we'll call it B. Let's go back to the Pythagorean theorem. We'll have a half of C squared plus B squared is equal to C squared. We can expand that a little. A half of C squared is equal to a fourth of C squared. We'll keep our B squared and our C squared. I'll move the fourth of C squared to the right side. This gives me B squared is C squared minus a fourth of C squared. We simplify that to B squared is 3/4 of C squared, and then take the square root of both sides. The square root of b squared is just b. The square root of 3 over the square root of 4 I separated, and I took the square root of c squared, which is just c. I can simplify the square root of 4 to be a 2. This says that b is equal to square root of 3 over 2 times c. So our sides for the 30, 60, 90 say across from 30 is a half of c, across from 60 is a square root of 3 over 2c, and then the hypotenuse is c. What's important here is all of the sides are related to the hypotenuse. Let's find some missing sides. Given the hypotenuse is 18, we're going to find the other two sides. I know across from 30, I'll have a half of the hypotenuse. A half half of 18 is 9. I know the side across from 60 will be square root of 3 over 2 times the hypotenuse. In this case, we have the square root of 3 over 2 times 18, which simplifies to 9 square root of 3. In dealing with these triangles, make sure you pay attention to where the 30 and 60 are located. In the next one, I give you a hypotenuse of 4, and we want to find the other two sides. Again, I go across from 30, and I multiply by a half. A half of 4 gives me 2. Then across from 60, I have the square root of 3 over 2 times the hypotenuse of 4. That simplifies to 2 square root of 3. Let's take a look at our trig functions for a 30, 60, 90 triangle. The sine of 30 is going to be a half of s over s. The s's cancel, so I have sine of 30 is equal to 1 half. The cosine of 30 degrees is going to be the square root of 3 over 2 times s divided by s. The s's cancel to give us the square root of 3 over 2 as our solution. Tangent of 30 degrees will be the opposite, which is a half of s, over the adjacent, which is the square root of 3 over 2 times s. One more time we see the s's cancel. I need to multiply the half by the reciprocal of the square root of 3 over 2. That's 2 over the square root of 3. Now the 2's cancel, but I have the square root of 3 on the bottom, which I need to rationalize. So multiplying by the square root of 3 over the square root of 3 gives me the square root of 3 over 3 as my solution. If we exchange the angles and find sine, cosine, and tangent, we'll see that we have similar values that occur at different places. The sine of 60 degrees will be the square root of 3 over 2s divided by s. This simplifies to the square root of 3 over 2. Cosine of 60 degrees will be the adjacent, which is 1 half of s, divided by s, which simplifies to 1 half. Then our tangent of 60 degrees will be the square root of 3 over 2s divided by a half of s. The s's cancel. I still have the square root of 3 over 2, but now I want to multiply by the reciprocal of 1 half, which is just 2 over 1. The 2's cancel, and my final solution is the square root of 3. We went through a lot in this video. I want to finish by giving us a summarized table of what we found out. Notice in the table I give the angles both in degrees and in radians because it's good for you to practice going back and forth between the two. You can see that the sine of 30 is a half, sine of 45 is square root of 2 over 2, sine of 60 is square root of 3 over 2. Notice that the values increase as we go from 30, 45, and 60. Cosine is the opposite. Cosine starts at the square root of 3 over 2 at 30 degrees. It's equal to square root of 2 over 2 at 45 degrees, and it's equal to 1 half at 60 degrees. Tangent is square root of 3 over 3 at 30 degrees. It's equal to 1 at 45 degrees, and it's equal to the square root of 3 at 60 degrees. Just like it's important to know degrees and radians for special angles, it's important to know sine, cosine, and tangent of these special angles. As always, the more you practice, the better you'll get.